Bismillahirrahmanirrahim. Assalamu alaikum dear students. You are watching Study with Sheraz, and in today's lecture we are going to discuss about the measurement of electronegativity. Basically, there are many methods that are devised to measure the value of electronegativity of any atom, but here we have given the most accepted three methods for the determination of the electronegativity. So first of all, the most accepted method is the Pauling method. And you people know that Pauling was a scientist who gave a scale upon which the electronegativity values are represented and that are extensively used in the field of chemistry. So Pauling gave a method. His scale was based on the bond energies of the molecules. He thought that if there are two elements A and B and they combine to form a molecule that is AB. So if a molecule AB is existing, the bond energy of the AB must be greater than that of the A and B. So that's why it is existing. So here is written the equation that is showing the formation of a hypothetical molecule A and B. So if A element combines with B element to form a hypothetical molecule AB. So AB should be more stable as compared to both A and B. Its bond energy must be greater than that of the bond energies of the A and B. Why? He thought that there are two resonance forms for the molecule AB, and these are the resonance form. He thought that if a molecule is existing as AB, so there may be two resonance forms or two resonating structure. This structure is found by the heterolytic cleavage, in which the bond pair is shifted toward the atom B. So this structure exists in which B is bearing the negative charge, A is bearing the positive charge, and in this canonical form the electron pair is shifted to A. So A is bearing negative, B is bearing positive, and you people have studied that more are the canonical forms or the resonating structures of a molecule, more would be its stability. So this AB is more stable because it is having two resonating structures, and because of these resonating structures he thought that the energy of AB molecule must be greater than the geometric mean of the bond energies of molecule AA and BB. So this was his idea, and based upon this idea he gave an equation that is excess energy. He thought that there must be excess energy associated with the AB molecule, and that excess energy was represented by the delta, and delta was called as the ionic resonance energy. So this excess energy is because of the resonating structure, as I explained earlier, and these structures are having ionic structure. That's why it was called as the ionic resonance energy, and that must be equal to the difference of energy between the molecule AB and the mean of the bond energies of molecule A2 and B2. The question here is why the energy of molecule AB is greater than that of the AA and BB. That was because of the difference of electronegativity. These resonating structures are basically based upon the difference of electronegativity. If the electronegativity of B is greater, this structure would be formed. If the electronegativity of A is greater, this structure would be formed. So these resonating structures are made by assuming that the electronegativity of A and B is not equal. He conceptualized that greater would be the difference of electronegativity between A and B, greater would be the excess energy. So he assumed that the difference of energy or excess energy can give us an idea about the difference of electronegativity between two elements A and B. He assumed that XA is the electronegativity of element A, XB is the electronegativity of element B. So XA minus XB is equal to EAB minus EAA into EBB. So he thought that the difference of electronegativity between A and B is equal to the excess energy. So here he equated both factors. So this equation can give us idea that if we know the excess energy, we can find out the values of the electronegativity for both elements. So what are the merits and demerits of this method? That's very important. It involves simple calculations. So this method is just quite simple. The second merit is it gives idea about the bond polarity. So this polarity can be shown here. The third one is conceptualizes that mostly reactions involve the enthalpy changes. He was having the idea that if any reaction is proceeding, there must be any heat chain that is associated with the reaction. And this method can be used to determine the bond lengths. So these are all the merits of it. Is having some demerits. The first and most important demerit is that electronegativity of any element is constant throughout. He was having the idea that electronegativity of any element should be constant, but that's not the fact. The electronegativity of element changes from compound to compound, molecule to molecule, because of many other factors that are also involved in determining the electronegativity of the element. And the second demerit was uncertainty in bond enthalpy values. He thought that there must be enthalpy changes, but he was not having idea that how much would be the enthalpy change. The next method of the determination of electronegativity is the Mulikan's method or Mulikan scale. So according to Mulikan, the electronegativity of any element is equal to the mean of the ionization energy and the electron affinity of an element. So ionization energy plus electron affinity divided by 2 would be equal to the xm. Xm means Mulikan electronegativity values. And Mulikan was having the idea that the hybridization state and some other factors must be involved in determining the value of the electronegativity of any element. The third scale for the determination of the electronegativity is the Allred and Rochow. So XAR is equal to 0.359 Z effective divided by R scale covalent. So Z effective is the effective atomic number and R covalent is covalent radii of the atom. Allred and Rochow related the value of electronegativity with the Z effective and the bond distance, or you can say the covalent radii. Mulikan related the value of electronegativity with the ionization energy and the electron affinity. So this was all about the measurement scales for the determination of the electronegativity. So we will meet in the next video. Up till then, Allah Hafiz.